Okay, so welcome back, and so we'll continue our discussion on the landfill site selection that we were doing it yesterday. We had looked at some of the regulatory requirements, some economic requirement, and also we have talked about some of the political compulsions many times you have in terms of selecting a site, and those are all realistic issues. So it's rather than saying that we don't have that problem, it's always better to identify the problem and address the problem rather than pretending that the problem does not exist, because wherever you go around the world, like I have, and as I have mentioned earlier in my discussions, that I had an opportunity to be at several countries and worked on waste management in several countries, and everywhere there will be some political interferences will be there. It's there, it's everywhere there, but somewhere it's too much, somewhere it's too less, and and basically we have to identify, we have to acknowledge that issue is there, and then work within the constraint that we have, rather than pretending that the problem does not exist, because if you pretend the problem does not exist, you will not come up with a solution for that problem. So we were looking at some of these political issues, social issues, before that economic issues, environmental issues. So we covered this in the earlier video. So today we'll start talking about that, how you actually go about doing that siting process. Like, what is the method in terms of how we go about scientifically or technically selecting the site. So what we do is we have it does involve a group of public and private officials. So ideally, in many parts in the many cities around the world, what they do is they involve advisory committee, and I think I mentioned to you that where the city I was living in Canada, very close to Toronto, I was actually co-chair of their solid waste management master plan committee, because I was a local professor at the university teaching in waste management. So of course they thought that the expertise is there, why not make use of that expertise. So I served as the this is the same advisory committee that they talk about. It's involved some sort of advisory community from the community. So you try to involve people from the community who knows about waste management. Just don't involve people who just happens to be like a members of a particular political party in the power, or somehow influential for some reason, but does not understand anything on waste management, does not have any background expertise on waste management. So we do need it's a public representative, but always try to identify a person who can really contribute something to it. That's how things can improve. So there are groups of public and private officials. They get together and then they'll go over this new siting activity, and it's always for the publicly owned. So I'm talking about publicly owned facilities. Most of the environmental facilities are publicly owned, and even if it's a private owned, it's on kind of on the public land. It's on like a build, operate, lease and transfer kind of BOLT or PPP model. Whatever model you go for, ultimately it is the public money which is going into the construction of these facilities. So we do engage public in the siting process. So it's an important aspect. Say if you don't engage the public, later on you will have more problems. So it's always better to engage the public in the siting process. And so it used to happen in ancient India. Like if you look at all the ancient histories, and when you start reading about different kingdoms we had over last, say, several thousand years, whatever history we have available in the history books, you see that there used to be a public consultation. There was where people from the community will come and they share their opinion, and then based on whatever is the best decided by the elected representative as well as the technical expertise and so community workers. And those names have changed today. So those names have become, earlier what it used to be in terms of happened in a court of a king. Now it is we have ministers, we have a federal, we have a bureaucracy, we have an executive, we have a judiciary, we have NGOs. So we need all these people on board, and then only we will, so that the project will prosper. Otherwise you start something and there will be somebody will go and do a PIL in the court, and then things keeps on hanging. So it's always better to keep people on board. And all the stakeholders has to understand that this needs to be done. So let's try to come up with a way to get this done rather than delaying it, because when you delay a project, as we very much well know as the citizen of this of our country, that many of our projects got delayed and over last several decades, and then delaying the project increases the cost. Many times the objective of the project is also lost, because we wanted to build it for something, but the situation has changed, or maybe the problem has become too big now, so the solution is too small. So those things comes in picture. So coming back here, so in terms of the siting process for the landfill, we try to have an advisory committee from the community, especially some people who are knowledgeable in this area, get public on board, and then they engage the public in the siting process. But what we do in the siting process, so let's look at that. So in the siting process, we start first by researching, identifying and excluding any location that are eliminated because of regulation. Earlier we talked about the regulation requirement in the previous video. So whatever those that, so first of all we'll say for the city or for the town of Kharagpur, if we have 5 or 6 locations in mind. So based on the town, if I'm the engineer, if I'm the solid waste engineer of town, or if I'm the public health person or the BDO or whatever position, I'm not that, so whoever is in charge, and the people who are in charge, they know what are the sites potentially can be used. So they said, okay, we have site A, site B, site C, site D. So all those site A, B, C, D, they go over the regulatory requirement. If some of these sites does not meet the regulatory requirement, that site is a strike off right now, it's straight away. So you research, you identify, and you research, identify and exclude any location. So research, identify and exclude any location that are eliminated because of regulation, because some will be automatically excluded. For example, the airports near MSW landfills, we cannot have MSW landfill near the airport, so that's already excluded. We already know that. Then if you have identify and exclude other location where siting is nearly impossibility. For example, areas with high population density. So you know that although it's maybe it meets the requirement, but there is no way a facility could be sited there. So rather than wasting your time and pretending that the problem is not there, let's face the problem and say that, okay, we'll not go to this side. Let's try to choose from whatever is left. So we go to the next step. So in terms of the next step, what we do is we develop a map. We have to develop the map with showing all the potential areas where the site could be located. So we come up with this town map of Kharagpur, and then so we have a let's say if it's, I will just draw a hypothetical map. So say if this is the map of Kharagpur, and then we have some sites identified. So these are our sites which is identified. So we just map these sites. Then what is next? So what we try to do is we break the locations into a grid, so uniform areas of land can be scored. So we put a certain like a grid system here, and based on that grid we will come up with certain scores, and I'll explain you what those scores we are talking about. Then we identify the issues which are important. So the issues could be, a community might view a groundwater contamination issue more important for them. They rely on groundwater. They don't have water supply system coming from a publicly owned water treatment plant yet. So they rely on their groundwater wells, their tube wells. So they may view that as a very critical. So that's one of the which we have to rank. During the ranking of the site, we have to give more weightage to that. And so as groundwater as being more important than the location to center of waste generation. So rather than, one of the critical point as we have been talking in this class is that collection is very expensive in terms of the municipal solid waste, but the collection is because the collection cost is very high. But at the same time, for some reason, say if there's one particular community, for them the groundwater protection is very critical. So in that case, that takes higher precedence, higher weightage is given to that as opposed to the collection cost, that we may incur more collection by having a site which is further away. So that's because If so that we have to rank different items, and then we give weightage to the different items, and I'll walk you through an example which will help you make it clear. So find those issues. So we have to first find those issues. For example, issues of contamination of groundwater. It might, how we'll do it? We can do it by the depth of the groundwater. And then there could be issue of endangered species. It might be the number of species per hectare in that area. So those are important. So then we put a scale on the site, where we have 0 score is for the terrible site, 5 is a great site. For example, for the depth of the groundwater, we can say 0 to 2 meter. If that's the great depth of the groundwater, then the score is 0. If 2 to 4 is 1, 6 to 8 is 4, and then anything greater than 8 is 5, because it's a good site. So similarly, for each and every parameters that we are interested in, what the local community is also interested in, get their buy-in, what they think is important for them, because ultimately they have to live in that community. So they will be living there in that community for several years. So we have to, in terms of getting that siting, so we score them. We score all these different, like based on different criteria. We do this scoring, and after this scoring is done, we come up with a total score. So we collect the measurement. So we have to go out and collect the data. So data will be groundwater depth data. There could be hydrogeological data. So based on all the different parameters that we are trying to find values for, which is important for that location, we go and collect measurements. So that's actually becomes part of the DPR as well. When you do the site selection, you have to do a DPR for that site selection, which site selection is also a part of the DPR. So you have to go and collect the measurement in terms of the groundwater depth, in terms of the soil profile, looking at the soil bearing capacity, looking at what is the flora and fauna around it. Do we have some surface water? How far is the surface water? And so all those different parameters which is important, we need to collect those data, and we compile the data. And of course, there is always a limit on how much new data can be collected. So there could be some existing data, we can use that, but many times we try to collect new data because that's the primary data. There is a difference between primary data and secondary data. If you have collected the data which has been compiled earlier, and then that's your secondary data, many times the secondary data is not you cannot rely on those secondary data. So if something is more critical, you go for primary data, and then you score the locations. So when we say scoring the location, for each location you come up with how well it meets the criteria. You have those 0, 1, 2, 5 ranking. So and then you rank them, and while what you do, you add them up. So you get, for the different parameters that you had say 3 sites or 4 sites, A, B, C, D. You add all these scores, and then you come up with a total score, and then you try to examine the top locations and try to select the best site from there. So you will have this score. Many times it may happen that while you have this top score, is site might be the best, but they are not all. There could be some other issues that come into play, and you may not pick the top one. You may pick the second one, or may pick the. So basically that depends on how things are at the local level. So this is how essentially the process works in terms of doing this site selection. Then once you have selected the site, once the site has been selected, the next thing is we have to have the facility permitting. We have to have some you go for building anything, you need to get the permit. So the next step is to collect the permit. So it doesn't matter that if you have agreed to a site, that means you are ready to go. So you have agreed to a site and you are ready to go, does not mean that you can start the construction. You have to get a permit. So there is a permitting process. So that's what the permit. As an engineer, you will go through some of this permit process when you work with any firm, any consulting firm. So you have to get a permit, or a construction firm. In most cases, you have to get the permit. The permit process can be lengthy. Many times it takes it's a lengthy process. Public input is allowed. So once you submit, so during the permit process, before you submit this permit document, or I should say in another way, as a part of the permit document, when you submit a permit document, you do have to submit at least the preliminary design of that facility. So the preliminary design of the facility has to be there as part of the permit document. That's important, and so that's it's very much it's needed for that. And the permit process, so when you do for this permit process, once you submit the permit, you may be asked certain questions, you have to reply to that questions. The permit is open to the public can view it, they can raise some objections, they can raise some concerns, and as an engineer of the consulting firm who is hired to do this permit process, or as a engineer, like whatever role you are, if you are involved in the permit process, you will may have to answer certain questions or that. So it's after most of the time permit takes few iterations. So the permit is rarely granted after first submittal. So you go through certain iterative process as part of the permit document, permit approval. So for large facilities, what happens is normally the owners will hire a consulting firm. They will hire an engineering consulting firm who will do the permit for them. The owner will meet with the consultant and describe what they want. So they will this is part of the permit process we are talking about. So owner will meet the consultant and they will explain to them what they want as part of that facility. In some cases, owner may have a good understanding and what they want. In many cases, they don't have actually good understanding. So as a consultant, as an environmental engineer, as a trained environmental engineer or an environmental professional, you will have to explain to them that this facility can what basically can be extracted from a facility like that. So that's there is a kind of there is like a meeting and other things has to take place. So it is a good idea to meet with the regulatory agency. So like when you're working on your permit, it's always a good idea, rather than I don't know it's in terms of how it works at the SPCB and CBCB areas. If somebody of you know, please post that on the discussion forum. But some of you may be aware actually who have done this kind of exercise. But usually it's in practice it's a good idea to meet the regulatory agency. So you meet the permit granting engineer or permit granting professional to ask them like what is their expectation. Many times the expectation listed on a piece of paper which comes out, it's not that clear. So it's subject to different interpretation by different engineers as well. So the engineer who will be working on that permit granting side, it's a good idea to go and meet that person. So schedule an appointment, go and meet, present like a very overview of what as a consulting company what you are trying to propose, and then get their feedback, so that when you submit the permit document, it's more in line with what they are expecting, rather than if there are too many surprises for them, it's a waste of time on your part, it's waste of time on the permit engineering part as well. So it would be a good practice. If the SPCB and CPCB does not do it, they should, I would rather think that they should do those kind of exercise to help expedite the process. So the engineering firm then they will they set to work, begin with a conceptual design. So that's they have to do a conceptual design of the facility. That's like a basic design. So the conceptual design of the facility has to be there. The permit application package usually includes permit application form, set of engineering drawing, and supporting engineering calculation. So we have to submit as part of the permit application. There is a standard form which you will get. So this is as part of the permit process. So there is a standard form which need to be filled in with all the details, and then we have a set of engineering drawings which needs to go with that, because if you are showing some basic engineering design, and then you show some basic engineering calculations which goes with that. So and the engineer also presents the conceptual design at the various level of completion. So submittal will normally in the form of engineering drawing. So in terms of 30% completion, how the drawings will look like, 60% completion, 90% completion. So there are the variety of drawings are there. There is an overall plot plan. Overall plot plan would be the big drawing which has all the details of the site, of the different facilities, major services will be shown and all that. Then for each of the unit you can have individual drawing going in detail. So that's and that how at 30%, 60%, 70% that you will have more details, so more services added or more at the different level of completion for that particular unit. So I have worked in petrochemical refineries area, so I can right now I can totally visualize all the drawings that we used to prepare, which used to go in the technical bid document and all those kind of stuff that we used to make for different petrochemicals refineries in India and abroad as well. So that's how this drawings are done. And as an engineer, as you know, engineering drawing is very important component. Basically, for engineers like us, our engineering drawing is the language. So I'm talking to you in English right now, but as an engineer, when we talk from our design office to the construction office or the vice versa, we actually talk through drawings. So drawing is our language. So we have to most of the drawings these days are made using computers, AutoCAD and all different softwares are out there. Let the people doing it on a board is you don't see that much. For a very small work, probably maybe, but most of works is done through the AutoCAD, but still the AutoCAD drawings has to be printed out and has to be sent on site, and the site people will do the construction. So at site you cannot have drawing on the computer and trying to use it. There may be these days with the high-tech automated construction, but most of the manual construction that we have, and I think 99% of the construction is manual construction, where you see that you need to have that physical drawing. So can check each and every aspect of the drawing while the construction is going on. So for the construction engineers, these drawings are very important. And to understand how the plant will look like, also the drawings are important. That's why at 30%, 60%, 90% at different levels drawings are made. So once the engineer will sign and submit the permit application. In many countries, this signature of the permit application can be done only by professional engineers. So you can go for professional engineering license. In India, we have something called chartered engineers. I am a chartered engineer myself, which is a institution of Engineers India. They do provide the chartered engineering certificate based on your credentials. And of course, I think most of us are members of Institution of Engineers India, and then there are different level of membership. But chartered engineers are kind of the Indian equivalent of professional engineers, or PE or PEng, that you see in US, Canada and other places. So the permit reviewers, so once it's submitted, the permit reviewer will spend some time to grant the permit or to ask more questions. So they raise request for additional information. So many times you will have this RAI coming in, which is called request for additional information. So the permit engineer will ask for more information so that this permit document can be evaluated. So the engineer has a defined period of time. So within that, so then you have a defined period. Within that time, you need to respond back to the permit granting authority. So and that's this is how the process continues. So once you have that, once the permit reviewer is satisfied, so those RAI could be multiple times. So that request for additional information may come multiple times. So once this permit reviewer is satisfied, after it has So once this permit reviewer is satisfied with your, they will issue a notice of intent to issue the permit. So you will get a permit intent to issue the permit. At this point, the product has to be advertised. So that's the typical procedure, and I'm talking about the global best practice that is happening. So at this point, the project has to be advertised. The public is allowed to comment. So public can file a hearing in the court. So they can look at the project, they can know what is the proposal, and they can go on court, or they can, if they have some issues, they can raise that issues through any public forum or coming directly to the agency which is trying to implement this project. So if it doesn't get held up, so which always in a democratic country, this is all it can get held up due to some law issue or the other. But if it doesn't get held up, the permit engineer will issue the permit along with site specific permit conditions. So it says issue the permit along with what are the conditions that goes along with the terms and conditions. Like you get anything today, like a cell phone SIM card or anything, you have those terms and conditions. Credit card terms and conditions. For everything there are terms and conditions. You look at the back, there will be terms and conditions. So similarly here, where the permit document is given, permit is approved, but with certain terms and conditions to maintain the uniformity of activity throughout the country. So in terms of the professional public practice issues, what we are talking now is actually professional practice issues. So as an engineer, what we do as a professional engineer, what things we work on. So in terms of the professional practice issues, the permit design process, we talked about the permitting process, and then we'll talk about the design process. So once the permit, we have to do the design. Then we also talk about a little bit about the construction process. So these three are the big areas of professional practice issues. So in terms of the design process, the bulk of the in design is for the solid waste management facility must be accomplished during the permitting process, at least the basic design. So because as part of the permit document, you need to submit all these design drawings at different level of completion. So at least the basic design, and to some extent even the detailed design, gets completed as part of the permitting process. The engineering firm will normally be hired. So typically the firm which is hired to do the permit application is hired to do the design as well. So because that becomes easier for them, for both the parties actually, for the client as well as the consulting company, to have to do both, so that they understand the problem, they have communicated with the permit granting authority, so they have a very clear understanding of the project, so they can give the permission to the project to go further. And since they already made some of the drawings as part of the permit application package, they can just use some additional resources and create more detailed drawing for the construction purposes. So the engineer firms will be hired for both permitting and design, and there are different milestones are reached at different times during the design. So there are different milestones. We have a completion levels for during the design, so 30% completion, 60% completion, permit level design, construction ready design. So there are different levels of design which goes through. There are different milestones for that. And then there are deliverables. So there is a permit level design deliverable. As a permit level, you have to do this permit application. You have engineering drawing, your permit application, engineering drawing, and there is an engineer's report. So basically you have some report about the site conditions, what your observation is, how this construction should be done, your suggestions for improvement of the different aspects of the project. So that goes into the engineer's report. So at this point, the engineering drawing may not be at the level required for construction yet, but it has some details, and then we have to make a construction ready design deliverables, which is the second level. So in construction ready design deliverable, you make the construction ready drawing, and then you have to have contract specification, because all the materials that you are proposing to buy, all the different stuff that will come in, what is the specification of those materials. So that is also very, very important in terms of project management. And most of these things are true for many of the projects, in environmental and non-environmental projects. It's not only for the solid waste, but the basic concepts of these what we have been talking about in this video is kind of general. It can be applied to water, wastewater, air, solid waste, and other fields as well. So it's in terms of the engineering drawing, there are many sets of engineering drawings are made. So there are pre-construction, pre-permit application drawing for internal and client reference. So you make some drawings which is mostly internal between the different offices, because you will have mechanical engineer, civil engineer, instrumentation, chemical, there are electrical. So all these different people will be working on. So they share at least the basic drawing, and most of this basic drawing is actually done by the civil engineering department of that consulting firm. The civil people, they do the basic big picture layout, and then the electricals and other things will come into their area, and they will develop more detailed drawing for the electrical components. Mechanical will do it for the mechanical components, and those details actually again has to be merged into this overall drawing, which is done by civil people. So there are many different engineering drawings. Pre-permit application drawing, 30%, 60%, we talked about that. Final permit application, there is one. Then construction ready drawing, and then as-built drawing. As-built drawing is the one which we haven't talked about yet. As-built drawing is the one which you make at the completion of the project. So once as-built, that means the construction is stopped now. So this drawing depicts what is the condition, what are the details of as-built structure. The structure is already built. Why this drawing is important? Why this as-built drawings? Up to construction ready, we know that we need to do the construction drawing to make the construction done. And once we have checked everything is okay, we do this QA QC check, we put this we put some of in terms of construction quality assurance, quality control, and all those things we do. But even after that, the people have already moved in and they are trying to use this stuff. But we stress on having a good as-built drawings. The reason for that is that, say if you go for an expansion later on, you go for any expansion later on, you need to really know where are your services, where are the pipes going, which direction, and which pipe is what. So because after 10-15 years, most of the people working in the consulting firm may not be there, or they will be too old to remember. And then you have this, you go to a site where you don't have a good as-built drawings made, and then it becomes a nightmare. My first project after I graduated with my BTech degree from this institute in late 90s, my first project was on MRPL expansion, which is Mangalore Refineries Petrochemicals Limited phase 2 at we worked at MRPL phase 2, which is very close to Mangalore. So that's there. We had some issues with as-built drawings. So since we were working on phase 2, phase 1 facilities were already there, but the phase 1 as-built drawings were not done very well. So there was, although it was okay for most part, but there was days when we will actually scratch our head, because we'll see that we'll suggest certain news for facilities, and then from the site we'll get a notice saying that cannot be done. We already have a lot of falling going on. There is a lot of other pipes already there. So those information is not depicted very clearly in the as-built drawing, and that creates a lot of problem for people working on in expansion of these kind of project. So with that, let's with that note, let's try to stop this video. We'll stop here, and then we'll continue some of more discussion in terms of the design process and other stuff in the next video. I hope to complete this discussion regarding this landfill disposal in the next video. So with this, I think we are almost towards the end of 9th week. So we'll get into 10th week from next. So keep posting your questions on discussion board. We will be happy to respond. If you have any queries, we will try to answer. And take the quiz, and those who are preparing for the exam, do it well, and then we'll also help you. That help is for everyone actually, whether you're preparing for exam or not. There will be certain example problem videos coming up towards the end of this set of lectures, and where you can have we will have example problem. We have some several example problem as part of the course content as well, but that will be some more to help you for the exam. So with that, thank you, and I look forward to seeing you again in the next video.